evening, guys. Welcome back to my channel. So the last video were seeing about some problems in binomial distribution. Today we'll go with the next distribution, which is Poisson distribution. Okay. So binomial and Poisson are more or less the same, but it's just a simple. You can say it is like a limiting case. We'll see what it is. Okay. Poisson. What is Poisson distribution? So now, when in the binomial distribution, what did we see? There should be a fixed n, which is the number of trials, and the success probability, and the x, which probability we have to find that one. Now, when n goes large and large, let's say n becomes 20 or 200 or 2000. 2000 experiments can be easily performed. But can you imagine 2000 C5? Can this value be found? How will you find? Until and unless you have a calculator, like specialized calculator, scientific calculator, you cannot, it's not possible to find 2000 factorial, okay? I don't think you can find 2000 factorial in any calculator also. But there are binomial distribution calculators available online. Maybe using that you can find. But when n is approaching to infinity, what does infinity mean? So in our case, 2000 is also infinity, okay? Because it is very huge number. Okay, how huge that should be, I'll tell you that, okay? And our p should be approaching to zero, which means what? Let's say if you take an example, n is equal to 2000 as we saw, and p's value will be 0.002. This is, can you see this? This is infinity when compared to this, and this is very, very, very small, which is like almost zero when compared to this, correct? In such cases, we will apply Poisson distribution. Okay, this is the condition. We saw the condition. Okay, this is the condition where you will apply the Poisson distribution. So condition is over. What is next in our list? PMF. We'll see what is the PMF. Okay, we are taking the uh, binomial distribution PMF itself. NCX, P power x, Q power n minus x. Now we'll assume, okay, we'll assume this product of n and p is some lambda. Okay, we'll assume that. Okay, say, which means lambda is not any defined constant. We're just assuming it to be a lambda. Okay, instead of using np everywhere, I'm just assuming that as lambda. Okay, now what did I do? What did I tell? N and p are like n is infinitely large and p is infinitely small. So now we will expand this. Okay, n factorial by x factorial into n minus x factorial. What is p? P can be written as lambda by n. Correct. P can be written as lambda by n power x. And similarly, what is q? Q is 1 by 1 minus p. So it can be written as 1 by lambda by n, 1 minus lambda by n. So 1 minus lambda by n power n minus x. Okay. Now see the beauty. Okay. Now you can write it like this. Okay. N factorial into lambda power x into what is you keep 1 minus lambda power n here, and in the denominator you do x factorial into n minus x factorial into n power x into 1 minus lambda by n power x, correct? I'm just splitting it and writing, splitting as in splitting n minus x as 1 minus lambda by n power n by 1 minus lambda by n power x. Okay, now n power x can be written as, what is n power x? N power x can be written as, sorry, n power x can be written as n into n into n, so on, correct? And similarly, n factorial can be written as n into n minus 1 into n minus 2 into so on up to n minus x plus x minus 1 into finally n minus 6 factorial, correct? And yeah, this is still remains. 1 minus lambda by n power n. Okay. Now in the denominator, if you see, I'm splitting n power x as n into n into n into x times. I'll let and show n into n into n into so on up to n. Now your n minus 6 factorial remains as it is. 1 minus lambda by n power x also remains. Now n minus x factorial and minus 6 factorial cancels. Now distribute this n to every term in the numerator. N by n is what? 1. N minus 1 by n is what? 1 minus 1 by n. N minus 2 by n is what? 1 minus 2 by n. Similarly, if you see, you will get 1 minus x minus 1 by n into 1 minus lambda by n power n divided by still your x factorial is there, and x factorial follows here, and 1 minus lambda by n power x is also there. Okay, so when you see this, we know that n will tends to infinity. Okay, that is the condition. If n tends to infinity, what is 1 by n? Tends to 0. All of you know this, right? If 1 by a very big large number you do, it will almost tend to 0. 1 by, let's say, 10 million, if you do, it will be 0.000 something, just tending to 0. Okay, so everything will be 0, because 1 by n, if it is 0, 2 by n is also 0, 1 minus 0 is 1. So this 1 by n part, 2 by n part will go to 0. Similarly, x minus 1 by n part is also 0. Okay, so everything remaining is what? 1 into 1 into 1, similarly 1. And your this one. Okay, now this one will not go to 0. I'll tell you why. Okay, now uh, in the denominator you get x factorial. Lambda by n is what? Lambda by n is again 0. This will go to 0. 1 minus 0 will be 1, and x is nothing. X is constant. Like, it's not a constant, but it is not infinity, right? Only n is tending to infinity. So 1 power anything, any finite number, 1 power, let's say 5, 10, anything, it's 1, right? So you will get 1 here also. Now this everything is 1, this everything is 1. Now only thing you have to worry is, I missed something here. Okay, lambda power x, I left. Sorry, lambda power x is still there. Okay, into lambda power x. This is still there. Lambda power x is still there. Okay. Now, now comes the interesting part. Okay. Now, 1 minus lambda by n. I read it in some other color. Now, 1 minus lambda by n power n. This is what we calculate, okay? But this is not how, like, you cannot do the same how you did the other terms, because lambda by n will tend to 0. That is fine, because n tends to infinity, and 1 minus 0 is 1 only. But there's a power here. N is also infinity. This is of the form 1 power infinity. Can you remember something you studied in lower class? 1 power infinity is an indeterminate form. Out of 7 indeterminate forms in limits, 1 power infinity is another indeterminate form. How will you solve this? Let's say this is L. Now ln L. This solving of limit is, I'm not going to teach you. I'm just telling you how to do this. Okay. Ln L is nothing but n into your general limit is g of x into f of x minus 1, right? So g of x is there, and your f of x is here, minus 1 is also there. So 1 and 1 get cancels. Now ln L is equal to n into minus lambda by n. Now n by n second cancel, because n is not exactly in, n is not like 0 or something. Yeah, okay. So now it's actually, there's a fun part here also. You cannot actually cancel n's here. You know why? Because n is also infinity. So n into minus lambda by n, if you do, it is of the form infinity by infinity. What will you do for infinity by infinity? Use L'Hospital's rule. Remember L'Hospital's rule? If you differentiate the numerator with respect to n, you will get minus lambda. Okay. If you differentiate the denominator with respect to n, you'll get 1. I mean, it's also 1. Okay. What is 2x? When you differentiate 2x with respect to x, what is the answer? 2. is nothing but 2 is a constant which comes outside. X differentiate of x with respect to x is 1. So 2 into 1 will come 2. Similarly, minus lambda into n. When you differentiate minus lambda into n with respect to n itself, d by d. Why are you differentiate with respect to n? Because the function is with respect to n, right? D by dn of minus lambda n will be, if you take lambda outside, minus lambda, d by dn of n is 1. So again it is 1 only. So you get minus lambda, and the denominator is obviously 1. So this value is minus lambda. Now, so L is equal to what? Ln if you take e power minus lambda. Got it? So when you solve this limit of 1 minus lambda by n power n, you get e power minus lambda. So now the final PMF answer is, if you solve this, what did you get? E power minus lambda into lambda power x by x factorial. This is the formula for PMF. Now what is lambda here? Lambda is nothing but NP. X is nothing but the probability which you want to find, and n is nothing but number of trials. P is the success probability. Understood? Just revise it once. You start with the binomial theorem and use the concept of limiting binomial theorem where n tends to infinity and p tends to 0, and replace p and q with lambda by n and 1 by lambda power n. Distribute all the n which is in the denominator, n power x is there in the denominator, to all the terms in the n factorial, so that everywhere your 1 by n term comes, so that 1 by infinity will go to 0. So only ones remain, 1 remain, and lambda power x is still there, and denominator also 1 minus lambda by n is there, that also goes to 0. And similar, and now only the numerator part, this part is there, no, only this is the trickiest part here, because you should know calculation of limits. Okay, this is the part. So when you calculate this, it's because 1 power infinity form, you got e power minus lambda, and e power minus lambda, if you substitute, you get e power minus lambda into lambda power x by x factorial. Understood? I'll just draw a small line here so that you will not be confused. Okay. Okay. So this is the PMF formula. Now what is CDF formula? There is no formula as such, but how will you calculate CDF? CDF is calculated by f of x, which is equal to f of x less than equal to x. Do not forget the sigma. Okay. Now what is our guys, one more important thing here, the sigma goes from 0 to infinity. Why? Because your n tends to infinity. Remember, in the binomial theorem it was just n, it was finite number. Now it is, because it is infinity, you will put the limits as infinity. Now what is this? Sigma 0 to infinity. What is f of x? Of x is e power minus lambda to lambda power x by x factorial. You have to remember this PMF, CDF, everything. CDF you need not remember. Just do not forget to put the sigma part. But at least the PMF you have to, at least, not at least, you have to remember. Okay, there's no other go. PMF is very important. Okay, understood? So now, what is the next part remaining? We saw the condition where the n tends to, when n should tend to infinity, p should tends to 0, and using that we derived PMF. We saw CDF also. Now next we'll see the mean calculation. Similar to this, is also similar to binomial theorem only. Okay, when how we calculated mean in it's not binomial theorem. So I'm telling binomial things, binomial distribution. Okay, E of x is equal to sigma x into f of x. Now yes, this one goes from 0 to infinity. Okay, now sigma x into, what is the f of x? E power minus lambda into lambda power x by x factorial. Now similarly, similar to this, you can take your e power minus lambda outside. Okay, and you can take, you can put, I'm not writing the limits again. Okay, x can be written as x, no, x factorial can be written as x into x minus 1 factorial. Again x and x will get cancelled, so remaining is lambda power x by x minus 1 factorial. Okay, now I'm doing something, e power minus, similar to how we did in the binomial distribution, we took p outside, right? Here I'm taking lambda outside. Sigma lambda power x minus 1 divided by x minus 1 factorial. Can you see what is this sigma actually? Do you know the expansion of e power x? E power x expansion, the Maclaurin series. Everything is from your basics 11th and 12th. Okay. So, what is the expansion of e power x? This x power 0 by 0 factorial plus x power 1 by 1 factorial plus x square by 2 factorial, so on up to infinity is very important. Okay. Now, because we change the limit sorry, because we change the limit as sorry, the function is x minus 1 in terms of x minus 1, you have to change the limit also. Okay. So until third step it was 0 to infinity, 0 to infinity. But in the fourth step, because you changed the x minus 1, in fact here itself it should change, because if you write 0 minus 1 it will go to minus 1 factorial in the denominator. It's wrong. Because you changed x minus 1 here, your limit should go to 1 from 1 to infinity. So this was the 1 to infinity. Okay. Now just expand this and see. Okay. We expand this and see. Lambda power 1 minus 1 is 0 by 0 factorial plus lambda power 1 by 1 factorial, so on up to infinity. What is this? Isn't this e power lambda plus lambda? Okay. So everywhere your previous knowledge comes into picture. Okay. So e power minus lambda into lambda. This is e power lambda. E power lambda and e power minus lambda goes to 1. So 1 into lambda is lambda. So your mean of Poisson distribution is nothing but lambda, which is equal to what? NP. If you would have substituted, if you would have not taken lambda in the first place and proceeded with NP everywhere, is still correct only. Okay. Everywhere you need not write NP again and again. That's why we assumed it to be lambda, and fortunately we got lambda as the mean itself. Okay. Now you will see the beauty of Poisson distribution when you calculate the variance. Okay. Variance is what? E of, sorry, E of x square minus E of x the whole square. If you would have, if you saw the video of binomial distribution where we calculated mean and variance, you remember we did something like this: E of x into x minus 1 plus x minus E of x the whole square. Remember? And we brought in the E inside. E of x into x minus 1 plus E of x minus E of x the whole square. Now we focus only on E of x into x minus 1 part. E of x into x minus 1 will be sigma x into x minus 1 into f of x. What is f of x? E power minus lambda into lambda power x divided by x factorial. Your limit will go from 0 to infinity. Do not forget that. Now, similar to what we did in the previous, in the binomial distribution, we took x into x minus 1 there, and x into x minus 1 into x minus 2 factorial. Understood? Now, because we changed the denominator to x minus 2, your limit will now start from 2 to infinity. Got it? And your take that e power minus lambda also outside, and lambda power x. So here we have 2 till x minus 2, right? So take lambda square outside. Lambda square if you take, what will remain now? Lambda power x minus 2. Now x into x minus 1, x into x minus 1 will cancel. Now what is remaining? E power minus lambda into lambda square. Your sigma 2 to infinity lambda power x minus 2 by x minus 2 factorial. Can you see the similar function we got in calculation of mean also? Lambda power x minus 1 by x minus 1 factorial. Your limit was 1 to infinity. Now it is nothing but x minus 2 by x minus 2 factorial. Your limit is 2 to infinity. This is same. When you expand this, you again get lambda power 0 by 0 factorial plus lambda power 1 by 1 factorial. Again, you get the same thing to only get the result as what? E power lambda. Understood? So e power minus lambda and e power lambda will go to 1. lambda square will remain. Only lambda square will remain. Now bring the this equation. Okay. Now if you bring in this equation, lambda square is there, plus what is e power x? Mu only, which is lambda only, lambda, minus what is e power x the whole square? Lambda square. Can you see what is happening? You're getting the variance as the same as mean. You got lambda in mean also while calculating mean also, and you're getting lambda for variance also. That is the beauty of Poisson distribution, where your mean and variance has the same value, which is the lambda, and which is equal to NP. What is NP? NP is nothing product of the number of trials and the probability of success. So the conditions for Poisson distribution is nothing but your n should tend to infinity, your p should tend to 0. If n is tending to infinity and p is tending to 0, you can apply Poisson distribution wherein the PMF is equal to e power minus lambda into lambda power x by x factorial. Using this, you can calculate the CDF also, the cumulative distribution function. And finally, we found mu and variance as both lambda itself. Mu and variance is equal to lambda, which is equal to NP. So this is the summary of Poisson distribution, whatever we saw. One last important thing to tell. Now, what is n? How will we calculate value of n if we tell it is tending to infinity? Generally, okay, generally, if in the question they give they give that you have to use Poisson or binomial, you have to use it. Okay, no other way. But generally, any value of n greater than 30, you can use for Poisson. Now you can ask me, how will you calculate 20C3? So that's what in pen and paper exam, if they ask, they'll not ask very big numbers. Okay, but I think 20 or 25 till 30 you can calculate in calculators as well, scientific calculator. 20 factorial can be calculated in calculator, I guess. Okay, but if your n goes beyond 30, you should use Poisson distribution, because your n is tending to infinity. And there's one more catch also. P should be less than, let's take 0.05. If it is less than 0.05, use Poisson again. Okay, these two are very important to note. Okay, the value of n and p. Understood, guys? Okay, so this video we saw about the Poisson distribution, and how to the all the five we saw, right? Condition, PMF, CDF, mean and variance. Okay, so thank you for watching. If you have any doubts, you can ask me. Next, we will go on solving a few problems on Poisson distribution. After that, we will move to geometric, then hypergeometric, then negative binomial, and uniform is still pending. Four distributions are pending. That will only be the distributions of discrete. After the continuous will come. Okay. Thank you guys. Bye.